All right, good night to everyone. Good night. Can you guys hear me?
Yes, sir.
All right, can you guys see my screen?
Yes, sir.
All right, great. So let's make a start. We're already late into the night, so let's get into everything. Now, everything that we need to learn for programming, that's what we're starting with tonight, programming. Now, programming has about three major chapters that we need to cover. So, if we were to look at it from the textbook perspective, so you guys should have this file here, the textbook. So, this is the textbook with all of the notes inside of it, and we're starting with chapter 9. So, chapter 9, we're looking at problem solving and program design. Then, when we're finished with that chapter, we're moving on to program implementation. And then, after that, our final chapter, good night, is going to be programming with Pascal. Now, this final chapter here, chapter 12, we won't go so much into it. We might not even go into it at all, because when it comes to CXC, for this topic of programming, we have what is called different programming languages. So if you were to ever Google that, so examples of programming languages, we have some examples here. So whenever you want to create a program, you use what is called a programming language. Now, a programming language is a type of written language that tells the computer what to do. So, you use a programming language to create a program, and that program basically carries out a specific action, a specific task. Now, these are some examples here. You have Python, you have Ruby, you have Java, JavaScript, C, C++. These are examples of programming languages. So just like how we have different languages that we speak, English, Spanish, French, Dutch, Portuguese, and so on, similarly, we have different programming languages. So basically, we have different methods of creating a program, hence different programming languages. Now, with that in mind, Visual Basic chapter 12 is one of such programming language. And if you notice chapter 11, it's programming with Pascal. That is another programming language. Now, for CXC purposes, we don't actually need to get into detail about a specific programming language. So it's not so much so how to program with a particular programming language, such as Pascal, Visual Basic, and so on, or Python, and so on. It's more of the design of that program. So it's not more about creating the program, it's more about what's happening behind the scenes. So that is why the focus, or my focus on programming, is more of what is programming basically. What is the idea behind programming? So that's why we have to cover what is problem solving, how to design a program, and then how to actually implement that program. That's what we'll be looking at. So before we actually create a program, we must know all of the how should I put it? All of the design that must come first before you actually create a program. You don't just go and create a program just like that. So for those example of programming language, let me go to image, and that's going to give you an example. So for instance, these codes that you're seeing here, why is it not allowing me to zoom? Yeah, these codes that you're seeing here right now, this is a program language. Let me see what program language it is. Not showing me a name, but this is an example of a program language. This is an example of a program that is being created. Now, before you actually go and start typing this program, you have to plan how to create this program. What should be in the program? That's what you actually have to do. So to get us started, are you guys following so far though?
Yes, sir.
Alright, great. Remember, I need your responses. I want you guys to understand programming, this topic of program that we're going to cover for the rest of fifth form is going to be challenging. It is going to be your most challenging topic, and it happens every year. It will be your most challenging topic. I'm not trying to scare you, but that is the fact. And that fact comes up because children, students, they don't want to think. They don't want to actually put into action what they're supposed to be learning. So all of this information here, some of you right now, you're asking yourself, why I got to learn programming? Isn't that true? Are some of you asking yourself that?
Yes, sir.
Yeah. Some of you are asking yourself, why do I have to learn programming? What purpose will it serve me in the future? I'm not even doing anything in IT in the future. Why do I have to learn programming? Well, it's just like if you're in the science stream. It's just like if you're in the tech stream. You're going to study all of these science subjects. You're going to study chemistry, you're going to study physics, you're going to study biology, integrated science, HSB, and all them technical subjects you're going to study. But in the future, are you going to use all of those subjects? Are you going to use everything you learn in those subjects? Will you? No answers? Or you don't know? You may not, but the fact is that you will not. You will not use everything that you're going to learn in any one of your subjects. But even though you will not use everything you're going to learn, especially let's focus back on programming. Even though you're not going to put into practice everything that you're going to learn, what you're supposed to actually take away is the skills that you get from learning that topic. Like for instance, all of you that are in the science stream and the tech stream, you're going to be doing science subjects and you got to do labs. Now, the purpose of those labs is actually to teach you how to do research. So later on in life, when you have to go and do a research, when you have to go and further your studies and do a research, you know how to carry out a proper research. That is one of the goal or one of the aim of completing all of those labs. Similarly, when it comes to programming, if you notice, the very first topic, the title, the very first topic is called problem solving. This entire chapter 9 is called problem solving and program design. And what it actually teaches you is not only how to program, but it also teaches you how to solve problems that you have in your life. So if you have any difficulties in your life, if you have any issues, it teaches you a skill as to how you can resolve it in a more practical manner. Instead of you, because sometimes you might have a problem and you don't know what to do. But then you might wonder, your friend got the same problem and they just get through fine with this problem. They're not stressing, they're not crying, they're not overreacting, and you wonder why. And the simple answer could be, they know how to react to the problem. They know how to handle it. They know what they could do to try to solve this problem. So similarly, in that line, this entire chapter 9, it basically teaches you how to solve problems, not only for programming, but it teaches you a line of thinking, how to think. When you're finished with, even when you're finished considering this topic here, when you have issues from tomorrow or the next day, later on, couple weeks from now, you're gonna realize that you can actually think in this same manner. You can think in this logical way, and that can help you to resolve a lot of issues that you have, that you face on a daily basis. So whatever you learn is not only about what you're learning, it could be the hidden skills behind of it. What is it actually teaching you? What is the practical part of it? So programming is not only about creating a program. That's not the only goal. One of the major goal is how to solve problems, how to think logically, how to think practically. And with that in mind, it helps you to process things better. So that's our goal for basically this entire chapter 9 that we are going to be covering. Are you guys with me so far?
Yes, sir.
Yes, sir.
All right, great.
Yes, sir.
Now remember, as I'm going through, as I said, this is a very challenging topic. I'm going to take my time. I'm going to go through each part step by step. As I said, we can't just jump into creating a program. That is not the process. That's not the correct manner. You don't just go and jump into creating a program. Even for your exam that is coming up in a few months, it's not only about creating a program. You have to learn all of the design, all of the principles, all of the rules, all of the laws that you must follow when it comes to creating this program. So that's everything that is leading up to chapter 11, because chapter 11 is actually when you're going to start creating this program. I think chapter 10, not so much so, could be. When we go through it, we can see. But the entire chapter 9 is more of designing that program, how to plan for that program. So as I'm going through, if you have any questions, if you have any confusion, if you have any comments, please let me know, because it's for you to learn. I already know all of this. It's for you to learn to pass your exam. Programming always comes on your CSEC exam, IT CSEC exam. It always comes. Doesn't matter which year, they will always bring it. It will always be in your paper 1 exam. It will always be in the paper 2 exam. Both papers it will be in. So that's why it's very important for you to focus on programming. This year's exam, some of the students actually, when we asked them why they would have done poor for the grade, when I say poor, I'm talking about grade 2. Why they would have gotten a grade 2. But I'm not saying that a grade 2 is bad, but I know that these children got the potential to get a grade 1, but yet still they got a grade 2. And the reason why they got this grade 2 is because they did not focus on the programming part of IT, and that's what messed them up in the exam. So please ensure you're focusing. Please ensure if you have any questions, let me know. If I need to go over anything, let me know, so that we can have complete clarification on everything. Are we clear on that?
Yes, sir.
All right. Seems only a few persons are awake. So, our very first paragraph. The paragraph states that software is the name given to a computer program that tell or instruct the hardware how to work. This is third form work. So even what you would have covered in third form is very important for you to remember for exam purposes. So software, that is the name for computer programs. We call programs software. And what they actually do is that they tell the hardware, which is the physical parts of your computer, what to do. If you can remember from third form, hardware cannot do anything on its own. It cannot do anything, cannot work on its own. It must have software. So that is why we have programming, so that you can create a software to tell the hardware how to work. The paragraph continues. Software therefore includes computer programs that create system and application software. We would have also learned in third form, so this is your first point here, this is your second point. We would have also learned in third form that that software has two types. Kevin, do you have a question?
Yes, sir.
Alright. So software has two types. We have system software and we have application software. Those are two types of software. So whenever you create a program, it's going to fall under one of these two categories here, system or application. The paragraph continues. Each program exists because a problem first existed and a solution was needed to solve that problem. So every program had some sort of issue, and that program was developed to solve that issue. For example, let's think about the program spreadsheet that all of you are using to complete your SBA, this spreadsheet program here. What issue would there have been that we had to create a spreadsheet program? What do you think?
Sort of management and maintenance of records.
Good, that could be one. Akila?
Sir, I was going to say practically the same thing.
Okay.
Managing and keeping the files organized might have been a problem.
Okay,
So-
good. As we know, back then, without computers, persons would have managed their records and their information manually. They would have written all the information in books and pages and flyers and other ledgers and so on physically. So having it on software, that could have relieved a lot of paper, relieved a lot of manual work. And what we're discussing right now is actually how you should be thinking to answer questions in your exam, because these are actually questions for your CSEC exam. Because they could ask you a question like that. What is the benefit of a spreadsheet application? It helps to reduce manual labor. It helps to reduce the amount of paper usage. What else would having this spreadsheet software solve? It helps to present data better. Good.
Share calculations.
Good. We can carry out calculations. Kavandi?
Data accuracy.
Data accuracy. Good. Very good. So we can carry out calculations faster. We can ensure data is accurate. Because remember, the software can check to see and ensure the data is accurate. If it was on a paper, you would have to manually go and look at it. So we get a lot of benefits from having this particular software. For data to be easily accessed, very good. So you don't have to go and search an entire cabinet of books. You can basically open a spreadsheet, hit Control and F, pull up the find option, type in exactly what you want, and you find easily what you're looking for. So we get a lot of benefits from this software here, and it is overcoming a lot of the negatives that data keeping would have incurred in the past, because those persons would have used ledgers and books and so on. So almost any software, basically any software, when you look at it, it has a benefit. It has some sort of problem for us, and we create it to solve an issue. Even for games, We have Need for Speed. We have Minecraft. We have Witcher. We have Assassin's Creed. What kind of issue would they have solved?
Sure, entertainment, teaching about the shit of things.
Boredom.
Good. Entertainment, boredom. What about cost? Would it have solved any issue with cost?
Yes, sir.
Hand-eye coordination. Yeah, I can help with that because games actually help you to develop certain skills. When it comes to game consoles, remember we have game consoles now, and these game consoles, they can be expensive. The PS4, the PS5, they can cost money. Now, instead of you going to invest in a whole console just to play one game, you can actually buy that particular game if it's on a computer, if it has a computer version, and play it right on the computer. And we know today a lot of you just download pirate games, and even more so, you get it for free. So that, in that sense there, it solves that problem there of lowering cost, lowering equipment, lowering hardware, and so on. So software we have today, it solves issues that we have. Now, are you guys clear in this entire paragraph here?
Yes, sir.
All right.
Yes, sir.
Good. Remember, if you have any questions, let me know. Now, we're heading into a very important part of programming: how to solve problems. What happens in the process of solving problems? So now we're entering into the realm of programming, this design and planning stage. So our next topic is solving a problem. So remember, we talked about a program is created to solve a problem. So how do we go about solving this problem now? Remember, I said we don't just jump to creating this program. There's steps that we have to carry out before. So what are these steps? The paragraph states you should first develop an algorithm to solve the problem. How many of you have heard this term algorithm before?
Sorry.
So for those of you who've had IT before, you would have heard that term algorithm. Anybody know what it means? Or has an idea as to what it is? Or what's your perception of it? Nothing? Alright. So, before you can solve a problem, repeated process, you can say so. A process that you have to repeat. A process that you have to carry out. So we can say it that way. A process that you have to carry out. So, before you can solve a problem, you have to, or you can say, before you create a program, you have to create what is called an algorithm. So, this algorithm, what is it? An algorithm is a sequence of precise instructions which results in the solution. An algorithm is a sequence of precise instructions which results in a solution. So you can think of it as being the program, but in actuality, or in reality, it is not the program. So think of it this way: all of you, all of us, we speak English, we write in English, but all of you, you're learning a foreign language in school. You're learning French, you're learning Spanish, you're learning Portuguese. Now, just for the sake of understanding this here, say for instance, you want to say something in French. We're just going to use that one foreign language. You want to say something in French. So, you want to say, why am I typing French? So you want to say something in French. Now you speak English. We all speak English. Not to the same degree, but we all speak English. Now, before you go and say you're writing a letter. Say we're gonna put that example. We're writing a letter in French. So we got a long letter that we want to write in French. Now, this letter that you're gonna write in French, what would be the first thing you would do? Let me see if anybody can figure out where the direction I'm headed. What would be the first thing you would do? You want?
Put our
So
address.
write
First
it
word is English.
Alright, let me hear Alvin.
So write our address.
Write
Our address.
write our address. Okay, you're talking about the actual letter. But I'm talking about so somebody actually said it correctly. You would actually write the letter in English. So, but the address, yeah, you write that. But would all of you, would you agree that you first write that letter in English?
Yes, sir.
No.
Physically,
No, sir.
No?
So in your head, we're doing letters the other day. Miss was saying write in Spanish first. Don't try and write in English,
Uh-huh.
because when you translate it, it can translate very weird. So just write in Spanish, and then you're going to translate in your mind. So no English.
Write in Spanish and then translate.
Sir, my French teacher is Miss Persico,
Mhm.
so I think that's self-explanatory.
Now, I guess they have their reasoning as to why they would do that. But just say for logical sake or for learning purposes. Chikacho? Yeah. So just say for learning purposes. It would be a little more logical that if you write, say you have a long letter, you write out exactly what you would want in this letter first in English. Wouldn't you say that is more logical? So say you want to remember exactly what you want in the letter. Wouldn't you first write everything in English? You have a very long letter. Wouldn't you first write everything in English? Wouldn't that be the logical thing to do? Like, yeah, Frank for say,
Sir, I
yeah.
would.
Yeah, Frank for say, yeah. To me, come see Frank for say, yeah, and the lady last shit tomorrow.
I'm sorry, what?
exactly.
So, if you were going back to the illustration, if you were to write a very long letter in French, the logical thing to do would be to write everything that you want in English first, and then you translate over into French, and that way you would get to see clearly if you translated everything. If I translated this first line correctly, if I translated the second line, if I translated the third, translated the fourth correctly, if I got everything over into French. Now, similarly, when it comes to programming, think of the French as the program language. The French is going to be the program language. So you don't just go and jump into creating the program first, because just like how you don't know how to speak French, you don't know how to type in this program language. For example, where is it? Where are my tabs? Any of you understand anything that you see here? Any of you understand anything that's happening there? Yes, no, maybe.
Sir, we understand the word individually, but like the meaning, no.
Good. You understand the word, you understand if, you understand print, but you don't understand what is actually happening. So it's kind of like Spanish. You might see a similar word, but you don't know if it means the same thing or it doesn't mean the same thing. Now, similarly, when it comes to the program language, it's going to be like French, it's going to be like Spanish, it's going to be like Portuguese. It might look similar. You might see a similar word, you might know this word, but you might not know how to use that particular word in the correct manner, if I using it in this correct sentence correctly, if I using it if I'm spelling it correctly, if I'm using it correctly, you might not know. So when it comes to programming, the very first thing you're going to do is actually the same thing. You're going to write it first in English. You're going to write it first in a language that you understand. And that is the algorithm. That is what you're actually doing when it comes to creating an algorithm. With an algorithm, you are writing in English words. You are writing, it doesn't only have to be English words, because if you are speaking French, if you are born in Italy and you are speaking French, then you would write this algorithm in French because that is the language you understand. If you were born in India and Hindi is the language that you speak on a daily basis, then you write this algorithm in Hindi. And that would be your algorithm. So what I'm trying to say, the algorithm is written in a language that you understand, that you are clear about. You're 100% clear that this is what is actually happening. So that there is the algorithm. You write in a sequence of precise instructions exactly what is to be carried out. And now, when you write this precise algorithm, it is just like how you're going to convert from one language to another. You're going to convert simply from English to French. Similarly, you're going to take this algorithm. You take this algorithm now that you wrote in English and you convert it over into the program language. That is what we do before we create a program. You create an algorithm in a language that you understand, and then you simply translate it now over into a program language. Think you guys are following?
Yes, sir.
Any questions?
Yes.
Did I confuse anybody? Remember, if you're confused, let me know, because you need to understand all of this. Mikhail, you following? Alright, good. So, an algorithm is a sequence of precise instructions which results in a solution. So that's your first description there of an algorithm. Your first point there, an algorithm. Your second point is that if your algorithm is vague and has conflicting logic, you will not get the correct answer. So this is kind of like what your language teachers might try to avoid. This is why they might tell you that don't write the sentence in English, try to write it directly in French and Spanish, because you might mess up the translation. So similarly with the algorithm, if you write this algorithm vague, if you have conflicting logic, if the algorithm does not make sense, if you don't write the algorithm correctly, then when you go and translate, you're going to have a hard time. So this algorithm actually has some rules that you must follow. It has some guidelines that you must follow. So just like how English, you guys are doing English in school. When you're going to write a sentence, does a sentence have a rule that you must follow? Do sentences have a rule?
Yes, sir.
Yeah. And is there a name for that rule? Is there like a general name?
Subject and verb agreement.
Good, that's it. But I'm looking for another name. Is there like a general name for all of these rules that you gotta follow when you're writing English? Ever heard of the term syntax?
Yes, sir, but not in English.
Yes, sir.
but not in English. Anyone, anyone ever heard of syntax in English? Or
Sir,
Nope.
when you're like, for example, when you're using the calculator or even spreadsheet, and you type something incorrect that the program cannot analyze, I like to say,
Mhm.
you would see syntax error or something of the sort.
Good, good. That's basically the idea. In maths, when you get a syntax error, um, or basically in maths, do you have anything for formula whereby you get a syntax error? Is there anything of that sort in maths?
Sir, the whole subject.
Good. And what does that mean?
Sir, it basically means that you did something wrong.
So in terms of what? In terms of the structure, the
The structure and the calculations.
good,
Try the structure. For example, if you forget a sign or something.
good, good. That is what I'm getting at. So just like in maths, there's going to be a rule that you must follow. How to create this formula, how to create this calculation. And when you don't follow that rule, you get what is called a syntax error. Now, similarly, in English, we also have syntaxes. I think it's when you get more deeper into English, we call it syntaxes, and that's actually the rule. That is the subject and verb agreement and all these other rules that you're gonna follow. That basically say that you gotta put the subject before the verb and all of these rules that you gotta follow. And when you don't follow that correctly, you get what is called a syntax error also. In programming, similarly, we have syntax error, and it's basically the same thing. You have rules that you must follow as to how you're going to structure the algorithm. And when you don't follow this rule, that is how you end up with what is called a syntax error. It's basically the same thing all around. Syntax is basically the rule of the structure. So, syntax, the arrangement of words and phrase to create well-formed sentences in English. In a language. So that's how you get syntax errors. It's even the same thing in English. Same thing in programming. Same thing in algorithm. Syntax is the rule that you must follow. Good. So that's that paragraph there. Are you guys clear in that paragraph?
Yes, sir.
Any questions?
Yes, sir.
Yes.
All right. Now, so remember we're looking at solving this problem. So I hope you guys are making your notes. The very first step in solving a problem is to create an algorithm. That's your very first step. To solve a problem, your very first step is to create an algorithm. Now, we're looking at the algorithm phase when it comes to problem solving, because in general we're looking at how to solve problems. So to solve a problem, you create a program. So let me try to draw a diagram of this so that you get an understanding. So you have a problem, and you're going to create a program to solve that problem. So you're going from problem to program. That's the line of path. But you cannot go directly from problem to program. So from the problem, you have to go to algorithm. So from the problem there, you create a algorithm. So that's where we're at right now. So we're solving that problem. Now we're heading into the algorithm phase. How do you create this algorithm now? That's what we're looking at. So in the first phase, there are 5 general steps. of this algorithm phase here. Step 1. You must clearly define the problem. So you must clearly state what is the problem. So this is actually going to be a part of your program called problem definition. So part of your SBA actually has this here. If we pull up your where is it? Your mark scheme. Please ensure you guys are following this here. You know what it looks like. So notice problem solving and programming. This is your mark scheme for that part of the SBA. And at the very bottom here, documentation, program documentation such as author, date, statement of problem. So notice it's here, statement of problem. So does this clearly define the problem that you want to solve? That's part of your SBA. So you must be able to see what is the problem. So please document these questions. When you're defining the problem, you're going to ask yourself, what is the problem? What's the cause of the problem? What are the effects of the problem? And that's basically it. You can talk about what is causing the problem. So basically you start off, what is that exactly the problem? So for instance, I'm going to use a simple example. The problem is that I am hungry. So that's the problem right now. I am hungry. Now, what caused this problem? I didn't eat enough today. Lunchtime, I barely get food. For dinner, I didn't eat so much again. I barely drinking water whole day. That's what's causing the problem. Now, what effects is this problem having on me? So personally, it's making me get a headache. It's making me upset. It's making me annoyed at everything everybody do. I'm feeling weak. And then, but when you think about effects, it's not only about how is it affecting the person, it could be also how it is affecting other persons around that person. How is it affecting persons around me? So how is it affecting my family? Is it making them upset because I am upset? Is it making them annoyed because I am annoyed? I am grumpy, so I'm having difficulties with them. So with that line of thought, whatever problem you're going to define, you have to ask those questions. You can't ask more questions, but these are the main ones you're going to be asking. What's the problem? What caused it? What is causing it to occur right now? What is it causing it to occur in the future? What effects is it having on me, persons in the neighborhood, persons around me, and so on? Are we clear on this so far?
Yes, sir.
Let me see. Anaya, are you following?
Yes, sir.
All right. So that is problem definition there. So please, when it comes time for you to create this for your SBA, please ensure you do that correctly. Now your second step. So we're at the second step now. You're going to propose some solutions. So what are these solutions now? That you're going to come up with some solutions and you're going to evaluate them. Propose solutions and evaluate. So you basically come up with any solution that comes to mind. So like for instance, we go back to the same situation, I am hungry. So you simply document now. What are some things I can do to solve this problem of hunger? Any suggestions?
Ask someone to make you something to eat.
Good. Ask somebody to make you something to eat. You go and make something to eat. You go and buy something to eat. You go and thief your neighbor food. So there's different solutions. and you document all of them. Doesn't matter how crazy they are, doesn't matter if they don't make sense, you document all of them. Even if they don't make complete sense, you document all of them. Even if the part where you're going to thief your neighbor food, you document it. And then you evaluate it now. You think about it. What's the advantage of, so when it comes to evaluating, you're going to look at the pros and the cons, or basically advantages and disadvantages. So you ask yourself, what's the benefit of having somebody cook for me? Is there any benefit to that?
Yes, it means not having to do it yourself.
Good. So you don't have to do it yourself. You don't have to get up and spend time, and you just sit down and the person cook for you and you eat. You're done there. But is there any disadvantage to that?
Yes.
Certain become too dependent on the person, and when they don't cook, they have to feed.
Good. You become dependent. Akila?
So there's high chances that the person don't know how to use seasoning.
Good. So the person might not cook well. That could be a disadvantage. The person doesn't know how to cook, or the person might not cook properly on that particular day, and you don't get a proper food. So all of these things you got to look at. What's the advantage? What's the disadvantage? Now, if you go and cook yourself, what's the advantage there? Is there any advantage?
So you can taste how I like.
Go ahead, Kavandi.
You can get it exactly how you want it.
Good. That's a benefit there. You get it exactly how you want it. So if you want no salt in your food, you get it exactly like that. If you don't want any sugar in your coffee, you get it exactly like that. But is there any disadvantage now? You gotta go and cook yourself.
So the fact that
You can take time off you doing something else.
You can what? Let me turn on.
It can take time off of you doing something else.
Good. So you can take time off of you doing something else. So you could have been spending that time. You could burn the food, because some of you might not know how to cook. So, and then you could have been using that time to do something else. All of those could be disadvantages there. Now let me look at the other one, the last one now. You're going to thief your neighbor food. Is there any advantage to that?
Not really. It's free.
Same, Arifa, same.
Yeah, you get free food. So you don't have to work for the food. You don't have to spend any money. So that's the advantage there, free food. But what's the
Sorry, you ain't got to owe nobody.
Good. So what's the disadvantage now?
Somebody catch and you get beat.
Good. You're catching a beat. Something you might go to jail. Yeah, you get a bad reputation in the neighborhood. So that's the idea there. That's what you need to be doing. You have this problem, you define the problem, you try to understand what's the problem, and you gotta come up with some solutions now. What are you gonna do to solve this problem? You document all of them. So if you notice, what we're doing right now, if you guys realize, we're not doing this to create a program. We're actually doing this for a real life scenario. So think of it this way now. Let me put it, because that's an actual situation there. All of you get hungry, and all of you end up with the same problem, and you ask yourself, why am I hungry? And you ask yourself, I didn't eat this morning, so why are you feeling hungry? I didn't and then you're gonna ask yourself now, what's some solution? So say tomorrow morning you walk into school and the problem is that you're feeling hungry. What can be some causes of this problem of you feeling hungry that you walk into school tomorrow morning? What's some causes?
Didn't have breakfast.
Good. So you run out of the house, you didn't have breakfast. Why you didn't have breakfast?
Didn't have time.
You didn't have time, you wake up late. So you had to run out of the house. You had to catch your bus and come down. Good. So that's what caused you to become hungry. Now how is that going to affect you now? Throughout the day, you're hungry.
You can't focus.
Good. You can't focus in class. How is that going?
Lightheaded.
How is that going to affect the teacher now? Will it affect the teacher?
Maybe.
Remember, if you got low energy, you grumpy, you upset that you eat, you head hurting, you can rest your head on the desk, and the lady can wanna know why you resting your head on the desk, and then she can abuse out you, and then you can abuse out she, because you understand what you're going through, but she don't understand what you're going through. So that's the effects there. It affecting you, and it affecting persons that are around you. Good. So that's the problem definition there. That's describing the problem. But what's some solutions now? You come in the morning, you're hungry. What's some solutions?
Buy something.
Buy something to eat. Where are you buying this food from?
Auntie Don.
Good. Now we end up with another scenario now. You come to school in the morning, Auntie Don doesn't show up. You end up with another problem. Auntie Don doesn't show up. So you see why now we have to get multiple solutions. Auntie Don doesn't appear, so we have to get more solutions. If Auntie Don is not there, what else can we do?
Eat your friend lunch.
Good. Teach your friend lunch. Combo
Order
do
something.
delivery. You order somewhere for somebody, but it's 9 o'clock in the morning. Combo don't open so early.
Buy the people at the back.
All the people they back. Hopefully they come. Alonzo to share food. You just bring food though. So that is the idea there. Now where are we heading? So as I said, if you notice, what we're doing so far, we're not actually thinking about a program. We're talking about a real life scenario. So this is problem solving, and this is how you can use it in a real life scenario. Well, let's look at another example again. You wake up, you just normally reach the school at 8:30 in the morning. You are a prefect of the school. You gotta reach the school for 8:30. You gotta reach the school for 8:45. You wake up in the morning, and you realize that the time is 8:30. How do you deal with that situation now? How would you deal with that situation now?
Sir, go back and sleep.
Go back and sleep. So that's one solution. Call in sick. I guess that's why a lot of y'all don't come to school.
Sir, I'm present every day. If I wake up that late, it make no sense I come out my house.
So you're gonna think it don't make any sense come out your house. But why are you thinking that way?
Because it's already after 8.
So you rather miss the whole day instead of half the day.
Yes.
But then is that logical thinking? So that's the
To me.
to you.
The possibility
So
of you
me
getting your
is
badge
logical.
suspended as a prefect for coming late is high. So
Well, that's what we're trying to help you to see, that we need to have a logical manner of thinking, that when you come up with problems from now on, think of what are some solutions to this problem. What are some things that I can do? I can stay home. So we go back to the same wake up late scenario. I can stay home. I can go hurry up and bathe and don't eat anything and until I get into school and eat and try to get to school as soon as possible. So you reach late but you get to school as soon as possible. Or you take your time, you do whatever you got to do, and you go into school for the next half day. So you got different solutions, and now you evaluate them now. So remember, we're still at step 2. We're looking at how to do things practically. We're looking at how to do things logically. You evaluate them now. You think, if I stay home, what's the advantage? What's the disadvantage? If I stay home and I got miss particle class, what she can do me to the next day? Gotta stay away from the lady class. And then when you realize you got shit in the morning and you can't stay away from the lady class, that's when you can realize that the disadvantage there is at a level that you can't go through with that disadvantage. So you end up taking another solution. You end up rushing, getting ready to school, and you head off even though you're going to reach there late. So the idea for problem solving is that whenever you have a problem, you try to understand what is causing this problem. Think of it logically. Even if you got to write down what's causing the problem, you write that down, you document it. Then you think of what can you do to solve it, and you look at each solution with their advantage and disadvantage, and you see which is the most practical one. So that's where we are with step 3 now. You select the most reasonable one, the one that makes the most sense, the one that is going to benefit you the most, the one that's going to help you out the most, the one that's actually going to solve that problem. Great. So that is the first 3 steps there of the algorithm phase. Are you guys following so far?
Yes, sir.
Yes, sir.
All right. So we're on to, let's see, Akhilesh, are you there? Following?
Yes, sir.
Okay, great. So we're on to step 4 now. Step 4 now, we have to now enter this phase of designing this algorithm. So now we are going to create this algorithm. So we're going to design an algorithm that is precise, well thought out to solve the problem. Remember we talked about a lot earlier about syntax and error and everything being logical and everything making sense. It's not supposed to be vague. It's not supposed to have any conflicting logic. Just like your sentences, it must flow smoothly. Similarly, your algorithm must follow the similar pattern. It must be precise, exactly what needs to be done. So when we get into problem algorithm, I'm going to go more into detail about that part there. So we're at the 4th step. We're designing this algorithm now. Later on I'm going to get into the details of designing this algorithm. And then after you're finished designing this algorithm now, you have to test this algorithm. So how do you test this algorithm? Once again, this is another part of your SBA that you need to remember. It is called a trace table. A trace table is used to test your algorithm. You must be sure your algorithm works correctly before you can write a program for it. So before you go and jump and create this program, before you jump and go and translate this program, it's like I don't have it anymore. It's like earlier when person said that how the teacher said you shouldn't translate from English to Spanish or English to French. Just go and write in French, because you're gonna get you might not translate correctly. That is why we have the trace table. The trace table is to ensure our algorithm is correct. So even before we go and translate, we are sure that the algorithm is going to work. We are sure that the program is going to work because we test it with a trace table. Are you guys clear on that?
Yes, sir.
Yes, sir.
Once again, if you have any questions, confusion, please let me know. So those are the 5 phases of the algorithm phase. Now, so remember, we're still looking at problem solving. We're trying to solve a problem. We have a problem. You have this problem. So how do we try to solve this problem? You create an algorithm. You enter this algorithm phase. You, step 1, define the problem. Step 2, propose a solution, evaluate it. Step 3, select the most reasonable one, whichever one makes more sense. Step 4, design the actual algorithm. And step 5, you test this algorithm, ensure the algorithm actually works. Now after you finish testing the algorithm, which is after you would have created the algorithm, now you're going to enter the next step of problem solving, which is implementation. So when it comes to problem solving, if you notice here, it mentions there's 2 phases. So those two phases is actually the algorithm phase and the implementation phase. So the two phases of problem solving is the algorithm phase and the implementation. So you develop an algorithm, and after you're finished developing this algorithm now, you have to implement this algorithm. How do you implement? You translate. You simply convert this algorithm now into a program language. So you translate your algorithm using a program language such as BASIC, Pascal, C, Visual Basic, and so on. So implementation phase, you're simply translating into a program language. Now, very important, I want you guys to take down list of popular programming languages. I want you guys to take down these examples here, because important for you to know examples of programming language. It will come on your exam. Not exactly, they won't ask you exactly they won't exactly ask you for a programming language. What they would ask you basically is which of the following is not a program language. That's what they would ask you. So you got to know what are some examples of programming languages so that you can be able to differentiate what is not a program language. So I'm just going to go back to the notes. The common ones, the very, very common ones that you should take note of is BASIC, Pascal, C, and Visual Basic. Please note that BASIC and Visual Basic is two different programming language. They have the same word BASIC, but they're two different programming language. So you have 4 programming languages here. Yeah, you have 4 here, and you have a few more here. So you can take note of these here. You have JavaScript, you have Python, you have Java, you have PHP, you have C#. So for those of you who know music, we call the hashtag sharp. So that's why we call this programming language C#. And then if you go back to the notes, if you notice there's a C, so we have C, we have C#, we have C++. So C with 2 plus at the end. Those are other examples of programming language. We have Swift and so on. Not necessary for you to know all of them, but I'm just indicating was the more popular ones, the ones that you're actually going to come across. So that's going to be Python, Java, JavaScript, C, C++, SQL. Those are the more popular ones that you will come across. You guys finished documenting that?
Yes, sir.
Alright, so let's continue. Good. So after you finish translating now, you're going to take this algorithm, you're going to translate it into a programming language of your choice. And that is actually why we create an algorithm first. We don't actually jump into creating a program. We create the algorithm first, because think of the algorithm as a blueprint. So just like how when you're going to build a house, you have a blueprint, and this blueprint is going to tell you exactly how to create this house. Similarly, your algorithm is a blueprint to create your program, and you're going to use this blueprint now, and you can basically choose any programming language. You can choose BASIC, you can choose C, you can choose Visual Basic, you can choose any one of the lists that you have here, Python, Java, JavaScript, anyone you can choose. And you just simply have to translate. You simply convert that algorithm over into the program language. That's why we create an algorithm, because it's easy for us to convert to any one of the program language. Whereas if we compare it to actual language, say for instance we had first written the document in French, and we want to now translate this letter now into Spanish, we might actually have to now go and translate this into English, because we know English, and then translate it over into Spanish. So, similar line of thought. If you go and create a program, for example, you jump and create the program in C++. You didn't create any algorithm at all. You just jump and create this program in C++. You might have a hard time if you want to go and convert it now into Java or another programming language. You can do it. If you're skilled enough, you can. Not saying it's impossible, but you might have a harder time. Whereas you can simply use the algorithm as the blueprint and go from the algorithm to Java, the algorithm to C++, the algorithm to basically any language. So that's why we have the algorithm. Now, so that's the first step of the implementation phase. Translate your algorithm into a program. Now, the second step, you're going to execute that program. Execute means to run that program. Another word you can use is run. Run that code or run that program or execute it, or what's another word? Execute, run. Let's stick to that for now. So execute or run that program. So you created the program and you're going to test it now to make sure that it is running, it is working correctly. Now, that's the second step of implementation. Your final step of implementation is to maintain the program. When you hear maintain the program, what comes to mind? What do you think you got to do? What would some things we have to do there? If you have to maintain, keep it updated, very good. If you have to maintain something, make sure it's free from errors, good, very good. If you got to maintain a car, what would that mean?
Sure, having regular checkups.
Have regular checkups, good. And the main goal is to ensure that the car running smoothly all the time, right? Checking the oil regularly, good. So you want to ensure this car functioning correctly all the time. Every day that you wake up, you're going to start the car, it starts correctly, you're not hearing any weird noises, it drives good. That's the purpose of this regular checkup of this car. That's the purpose of maintenance. Similarly, we have program maintenance. With program maintenance now, what we're doing, we're ensuring that this program is running correctly all the time. Now, what happens over time is that you might create this program one way. You might create this program this way. And what happens over time is that sometimes the instruction, sometimes the code, something you use might get outdated. Something of the sort might get outdated. Just like how something in your vehicle might get outdated or it might get worn out from overuse. Something might get outdated in the program. So what you got to do now is update that feature, update that code, update that part that is outdated and is no longer working. So that's maintenance. Maintain it to ensure that it's functioning correctly all the time. Now, so over time, your program is going to get what? There's a specific word that programs get over time. A specific term. Starts with B. Nobody? Programs get it over time.
Update.
Issues. We're talking about issues. What issues? It starts with the letter B. You guys know it.
Bad.
Baz. Bugs.
Sturbridge?
Bugs. Bugs. Yes, bugs. You guys never heard of that? Programs having bugs?
Oh, yes, sir. Yes, sir.
Yeah, you guys know about that. So that's what we call issues in programs. We say that they have bugs inside of it. Fun fact. Do you guys know why we say a program has bugs inside of it? Anybody know?
It has errors.
Yeah, it has errors, but how did we come up with this? How did we come up with actually calling it bugs? So, the very first computer is right here. On September 9, 1947, a team of computer scientists reported the world's first computer bug, a moth trapped in their computer at Harvard University. So a literal bug was in their computer causing an issue. They had a computer running and the computer was causing issues. It wasn't working correctly. And they weren't figuring out why. They weren't getting to as to why it was having these problems, why it wasn't working correctly. And I think it was a female. She actually was examining the computer, and she discovered this bug, a literal bug inside of the computer. Who was the person? I think it was a female. Yeah, Grace Hopper. And her last name literally had Hopper inside of it. Yeah. So this female, this scientist, she went to the computer and saw a literal bug inside of the computer, a moth inside of it. And that's what was causing issues in the computer. And that is how we end up with the term bug being the terminology of issues occurring in a computer. Was that interesting?
Yes.
Alright, so we covered a lot of information. I don't want to get into defining the problem because that has a lot of problems. So, a recap of everything that we have covered for tonight. So, we reviewed what is a software. A software is basically a program that tells the hardware what to do. Without software, hardware cannot work. There are two types of software. We have system software and application software. Now, in terms of problem solving, in terms of solving a problem, the very first stage is to create a algorithm. So that is the algorithm phase. And in that phase, you define the problem, come up with solution, select your solution, design your algorithm, and then test your algorithm. And those are the questions that you must be asking and the tools that you're going to use. Then after the algorithm phase, you implement the algorithm by translating the algorithm into your program language of your choice. Executing means that you run the program to see if it's working, and maintenance is to ensure that your program does not have any virtual or physical bugs inside of it. Any questions, comments, concerns, confusions about anything that we covered so far?
No, sir.
Alec, following so far?
Yes, sir.
Alright. Devika?
Yes, sir.
Alright. Shaniqua, Sierra, are you two following?
Yes, sir.
Alright, great. Alright, if no questions, we're going to stop here for tonight. If no questions, that's going to be the end of today's class. Enjoy the rest of your night. See you tomorrow.
Yes, sir.
Good night, sir.
Bye, sir.
Yes, good night.